Show you just a slightly harder example of using the getObstacle sensor. In this one, what we're going to do is we're actually going to follow the wall of around the perimeter. So first of all, we've got our usual when our script starts, which if you remember is up here under control. And then we initialize our robot, which is under robot right here. And then we have our center get equals getObstacle. So you remember we put in here in variable whatever we want to name our variable, and we then put the position that whichever sensor we want to get our data from. So I've set this to say that while my center sensor is reading less than 100, I want it to go forward and then keep checking to see if there's anything in front of it. And then once it finds something in front of it, it's going to back up a little bit, and then it's going to turn, and then it's going to check its left and right and center sensor. So it's going to check all three. And then if there's nothing in front of it and something on either side of it, so I have this if statement right here, which is a little bit complicated, but not too bad. So I have center less than 100, and then I put parentheses around this because I want one of these to be true. Left is greater than 100 or right is greater than 100. Then I want the robot to continue going forward. So this should make it follow the wall. So let's take a look at that. So we initialize our robot. Our robot goes forward. And now it sees the wall, it backs up a little bit, it turns, and it goes forward again. There it goes. So it should go all the way around because we've set it so that it will just keep going as long as there's nothing in front of it. The only way that it would stop in this case is if it got itself stuck inside of a little box, which if you had a different setup over here where you had a maze or something, that might actually happen. So I'm going to stop this simulation right now and close it. So let's go over this one more time. We start our script, we initialize our robot, we check our center sensor by setting the getObstacle function to a variable. We check to see if it's less than 100, and if it is, we go forward. Then we check it again, so we're checking it as it's going forward. And then once we find an obstacle in our way, we back up a little bit, we turn, we make a right turn, and then we check all of our sensors. And if we're along the wall and not out in the middle of the screen, then we will continue going forward. That's what this if statement does. So it checks to make sure that it's got something on either side of it. So both of these statements have to be true in order for it to keep going forward. So that's a slightly harder. Okay, I'm going to show you a slightly harder example of using the getObstacle block. What this program does is actually checks its obstacles, and if it sees one, it actually asks the person watching the simulation what kind of obstacle it's run into, and then based on the answer to that question, the robot does something different depending on what it's run into, because a robot doesn't really know whether it's run into a wall or a block or a ball or whatever it's run into. So we're going to tell it what it's run into, and then it's going to do something different based on that. So there's a couple of new things in here. I'm going to point out those new things really quickly, and then we'll run through this little program. Here is one new thing. This is called the answer block, and what that does is it asks, or it's the ask question block, sorry. What that does is it asks the person a question in a little pop-up window, and then you choose an answer from some choices, or you can type in an answer. Those blocks are also found under the senses section. They're near the top because these are all in alphabetical order. So you've got
ask question, and you can ask a question and this would have you type in the answer, or you can ask question, type in the question, and you give it a list of choices. And so what I have here is I've set, just like with the obstacle, you have to set this to a variable to store the answer in. And the question that I'm asking, I put it in quotes because it's a string. Um, I asked it, what am I bumping into? And then I've given it some choices. And these choices are also strings. Each word is in quotation marks and are separated by commas. And around this list of words is square brackets, and that's called a list. We're not really going to learn about lists, but this is one place where you will use them if you want to give your person answering the question some specific options, which I like to do so that I know exactly, if they type it in, you don't know exactly what you're going to get. They may give you something weird, and if you want to base robot movements or graphics or whatever on the answer to that question, then you want to know what the answer exactly is. Or if you're going to have a quiz and you want to know, that has to be a very specific answer. So that's one new thing. The other new thing is, well, there's two other new things. This is our, we have up here, if you remember, we have some statements. And we looked at this statement where we set a variable and we set it equal to something, and that could be a mathematical equation, or it could be a string, or it could be anything on the other side of the equal sign. And now we're going to use this other statement here, and what this does is it generates some random numbers. And what I've used this for in this program, and I just left the variable as result, and I've given it a minimum amount and a maximum amount. And what these are the degrees of the turn that the robot is going to make. So I wanted to make that random rather than giving it a specific, right angle or 45-degree angle or something like that, so that it would go, I wouldn't know exactly where it's going to go after it makes its move, so that it was sort of a random movement, which, you might want to do. So that's that. And then the final new thing that we're looking at is the taking a picture. So we can take a picture on our little robot camera and then show that picture. So those are down here under picture. And there is way down here at the bottom the show picture and take picture. And picture, like all the other functions, so you're just going to have to get used to this, is that you'll have a variable that you set the picture to, and you can give it a mode. It saves it as a JPEG. That's a general good default. So I'm going to set the variable to picture. I'm going to leave the mode as JPEG. And then just underneath that, I show, and you want to put your variable in here, whatever you said the picture was. So if I had said my picture, I would have my picture in here. And it's going to show that in a window, and you'll see this in action. Now these pictures are kind of funny because they're virtual pictures, but if we had a real robot, you would see real world pictures. So let's go through this program and see exactly what it does. It looks complicated, but it's really not that complicated. So we're going to have our usual when the script starts, we initialize our robot, and then I have this while loop. And what the while loop does, in this case, I've just set it to be true, which is its default. And what that does is it makes the program loop forever. We could put in here, while the obstacle is less than 0 or greater than 0 or whatever. We could put anything in there and it would stop when that condition became true. But we're just going to run this over and over again until we get tired of it, and then we can stop it. So the robot's going to go forward. It's going to check all 3 of its obstacles. So you see I have this set to center, and checking the center sensor, the left sensor, and the right sensor. And then I have an if statement where I check to see if there's anything at all near the robot. So before we checked just the one, see if there was something in front of it. And now we're going to check every single thing. So if there's anything in front of it, we're going to ask what that object is. So I have this statement down here that says center greater than 100 or right greater than 100, or left greater than 100. So if anything is around it, if it's greater than 100 at any of those sensor points, where it's going to stop and ask us what it's bumping into. So here's the stop statement, and that's under robot movements, like the other movements. And then here's our answer block, our ask question block. So we've got that set up to ask us what I'm bumping into. And then here's an if statement that checks the answer to see, okay, what did you answer, and what am I going to do with that? What do I need to do now that I know what I'm running into? So I've set that if answer is equal to wall, and we use a double equals when we're checking for whether two things are exactly equal. We use a single equals, like in this result equals random, to assign a value to a variable. So I like to think of this as is. So result is some random number between 0 and 100, and we don't know what that is right now. Or answer is whatever result comes from this function. So just remember your double equals when you're checking if statements for equality. And if it's a wall, it's going to run this code right here. So if you tell it it's running into a wall, it's going to back up a little bit. We're going to get a angle for it to turn. In fact, let's change our variable here to angle so that that makes a little more sense to us, so that we know what those things mean. So we're going to get an angle, and we're going to turn by that angle whatever comes out of this random number generator, and then we're going to go forward, and then we're going to check our obstacles again, and what it will do is go back up through the loop again. If our answer is equal to ball, if we tell it that it's running into the ball, it's going to take a picture of the ball, and then it's going to back up a little bit and then start actually probably going forward again. And if the answer is the block, we're going to do the same thing. We're going to take a picture of it. We're going to show that picture. We're going to back up a little bit. Now, this isn't the most perfect code in the world. I've tweaked it a little bit as I've seen the results, but sometimes the robot gets stuck places. It can't turn exactly. It bumps up too close to the wall. But it's still a pretty good program, and let's just watch it run. I'm going to move our simulator over a little bit because we want to see the ask question is going to pop up over here. So it's stopped. It's asking us what we're running into, and we're going to tell it it's running into, let me just pull this down a little bit, into the wall. It's backing up. It's going to turn, and notice that it turns, you know, somewhere like 175 or something. And it looks like it's going to maybe run into the ball. The ball is movable, so if it bumps it, it's going to bump across the screen, but it didn't. So it probably detected that on the right-hand side, on the right-hand sensor. It probably doesn't see it over on the left. It might see it a little bit on the center. And we're going to tell it that it's bumping into the ball. And so it's going to take a picture. So it took a little picture. And now you can tell it, yeah, you're still running into the ball. The ball's out of its way now, but still running into it. And now it's going to bump into this wall. So we'll tell it it's running into the wall. It's going to back up and turn. And now it's going to bump into the block. And we're going to tell it's running into the block. And because we don't tell it to turn after it's run into a block or the ball moves out of its way, but the block can't move out of its way. So this is going to go on forever. We're just going to lie to it and tell it it's running into the wall, so it'll turn out of its way. So you can see what that little program does. It gives you a little bit more interesting behavior, takes some pictures and does some fun things. So that's just a little bit more complicated example and might give you some ideas for some things that you can do too.